What is going on, everyone? Welcome back to another episode of Modern Ed. Today we're going to be going over condensing logarithms, something that is essential in order to solve some of the more complicated math problems you might be asked as you go forward. All right, so let's start off with a quick review, and let's get right into an easy, medium, and a hard problem. So, whenever you're condensing or expanding logarithms, all you're doing is basically either using one property or combining several properties to either make the logarithm as expanded as possible or as condensed as possible, depending on whether it's asking to, well, expand or condense. Makes sense, right? So let's make sure that we understand what those properties are. First up, we have the product rule, okay? We've covered this a few times in a previous video, as well as the quotient rule and power rule. Make sure you click those links in the description if you haven't covered those. But if you're looking at the product rule, all that says is that if you have the same base with two numbers being multiplied inside those parentheses, you could expand that logarithm so that way you are just adding each of those. So you have log base bx plus log base by. And then the quotient rule is just saying that, hey, if you are dividing two different things within the same logarithm, you can actually just subtract them in their own separate logarithms using the same base. And the power rule just means that if you have an exponent on whatever you are taking the logarithm of, well, all you could do is just take that and move it downwards so it is a coefficient, and then that is how you would just simplify. Really be simplified in just three easy steps. One, just identify the property that you can apply, or properties that you can apply. There's usually more than one. Step two, apply them. And then step three, simplify. Okay, it really is that easy. Just figure out what it is that you're doing, do it, and then simplify. All right, so let's start off with an easy problem to see how we can do this. Okay, so if we look at this, we have a log u minus log v. And remember that if it's never written, it is assumed that this is base 10. Okay, so if you have log base 10 of u, log base 10 of v, well, you're subtracting these two, so that means that we're going to be using our quotient property, meaning that we're going to condense this to say that, you know what, log base 10 is going to be u over v. And there we go. That's it. So instead of going from log u over v like we did in our previous video to writing it out as a subtraction problem, we're now going from the subtraction into the quotient rule. Okay, so we're just making it condensed. So now it's just one term instead of two. All right, let's check out a medium problem. All right, so I'm looking at 2 log base 5 of 25 minus log base 5 of 5. So when I want to condense these, I want to figure out what properties I have and see how I can use them. So one, I see a coefficient, and I know that if I take this coefficient up here, that is going to be using the power rule. And I also see the subtraction sign, which means that we're going to be using our quotient rule. All right, so let's actually do just that. Let me write log base 5 of 25 to the power of 2 minus log base 5 of 5. So knowing that, I got to think to myself, what else can I do? Well, it might actually just be simpler to write this one out right here. So if I have log base 5 of 25 squared minus log base 5 of 5, it might be easier to just square this out and see what we get. So let's actually rewrite this as log base 5 of 25 times 25, which is just going to be 625, minus log of 5 base 5. Now, you might be tempted to answer that, and you're more than welcome to actually do that because you might see what exponent we actually need to get this simplified. But if you notice that we have a subtraction sign here, we can actually just go ahead and use the quotient rule. So we can actually combine these two into one logarithm with a division sign. So what that would mean is that we would have log base 5 of 625 all over 5. And what does that give us? Well, that would mean that we would have log base 5 of 125. And then what that would mean is that we are now looking for a number that when we put as an exponent to a 5, it's going to give us 125. So again, we kind of did this loop-de-loop rule, meaning that if we took 5, raise it to an exponent, we should get this right here. So what exponent do we need to raise 5 to get 125? Well, that answer is just 3. 5 to the power of 3 is 125. Okay, now let's take a look a little bit at a harder problem, which might use more properties, but still the idea is just the same. So now we're looking at 6 log base 8 of 5 plus log base 8 of 6 divided by 3 plus log base 8 of 11 divided by 3. So this one clearly looks a little bit more difficult than our other ones, but if we just use the same exact approach and steps that we used before, we're going to solve this no problem. So let's say that we have 6 log 8 of 5. I can already see that this is going to be a power property. So I'm going to rewrite this as log base 8 of 5 to the power of 6. Plus, okay, I'm dividing by 1/3. I'm dividing by 3, which means that I'm multiplying by 1/3. So you can imagine that if I had kind of a 1/3 out here, and let me change the colors a little bit brighter. So if I had a 1/3 out here, you could think of 1/3 as that coefficient. So it might make more sense if I wrote it out like this. And I'll keep this one just the way it is right there. Okay. So if you think about how 6 was our coefficient and we moved it up here, well, 1/3 is just our coefficient, so we're going to move that up here. So now what I can do is rewrite this entire line as log base 8 of 6 to the power of 1/3 plus log base 8 of 11 to the power of 1/3. Okay, so now I got to think to myself, what else can I simplify? How do I make these into one logarithm? So if you want to figure out how to condense these three into one logarithm, well, notice how we have 5, 6. Okay, that's great. But we also have a base of 8, 8, and 8. And we have addition and addition, which means that we can use our quotient rule here. Because since we have the same base, log base 8, that means that 5 to the 6th times 6 to the 1/3 times 11 to the 1/3 can be written inside because of our product rule, okay? So we can write that as one logarithm just by using those properties. And then if you want to, you can keep simplifying. So I can now write log base 8. We're going to have 15,625. And then we're going to have, let's see here, so those are the same exponents. Okay, so we can write that as 66 to the power of 1/3. This is correct. You could also write as log base 8 of 15,625 times the cubic root of 66. That's also cool. There's ways to put this into your calculator where you can get an actual number. That's fine. But a lot of times you're going to be asked to solve this without a calculator and simplify it down to its most simplified state. And that's exactly what this would be. So again, there's different ways to write it, but this is the general idea. All you have to do is realize which properties you're using, whether it be quotient, product, or power, and just figure out how exactly you can use those to simplify, condense, simplify, and come up with either a numerical answer or have it be written as one logarithm, provided that they're the same base. All right, so I hope that was really helpful. Don't forget to like, comment, subscribe. Let us know if you need any homework help. Yeah, we'll catch you guys in the next one. Thank you.